We want to solve the equation sin 2x equals cos x for values of x between 0 and 360 degrees. Let's start with the equation. Sin 2x is equal to cos x. We know the identity. Sin 2a is identical to 2 sin a cos a. So we have 2 sin x cos x is equal to cos x. A common mistake here is just simply to cancel the cos x and say that 2 sin x is equal to 1. The reason that this is a mistake is because a solution to this equation is cos x is equal to 0. If cos x is equal to 0, 2 times sin x times cos x is 0, and cos x is 0. So this is a solution to the equation. And if we just cancel in the ways shown, then we would miss any solutions due to cos x being equal to 0. So we mustn't do this. A far safer way to proceed is to bring the cos x over to the left-hand side. Once we've done this, there's a common factor of cos x on this side. Open a bracket and we get 2 sin x minus 1. This tells us that either cos x is equal to 0 or that 2 sin x minus 1 is equal to 0. This rearranges to give sin x is equal to a half. If x is between 0 and 360, then the cosine of x is 0 if x is 90 degrees or 270 degrees. And we should know these values as we know the graph. For sin x equals a half, we look for the principal value. X is going to be the inverse sine of a half. This is a value we should know, but we can use the calculator to get 30 degrees. We then use our cast diagram, ASTC. 30 degrees is here, and for a sine, which is positive, the other one will be in the S quadrant. Symmetry tells us 30 degrees above 180. To find solutions from 0 to 360, start at 0, and the first one is at 30 degrees. Continue on, the next one is at 150 degrees, 30 degrees before 180. And then continuing, we don't meet any more solutions through to 360. So we can list out all of the solutions to this equation. We have 30 degrees, 90 degrees, 150 degrees, and finally 270 degrees.